you. So the title of my essay was BIM to FEM Transformation and Transfer, an ANSYS case study. So my supervisor was Professor Bostian, and my co-supervisor was Professor Tomo. So the goal of my thesis was to develop a methodology that streamlines the transfer of data from BIM to ANSYS. The objectives were really to review the current BIM and FEA practices in terms of modeling and storage of information in both platforms, the BIM and the FEA. And then next was to analyze the capabilities of data transfer. So how is data transfer within BIM softwares and also from BIM to FEA softwares? And also if there are any challenges for these transfer processes. And then by investigating these two was to investigate the pre-processing steps, whether there is need to develop any level of geometry or level of information for BIM elements. So finally was to design a methodology from this investigation and test out the methodology on a case study. So BIM delivers a digital model of both the physical and the functional characteristics of a structure. It's rich with information of the material and the geometry. And this forms a database for knowledge sharing. Whereas the finite element analysis helps structural engineers to simulate the real behavior of the as-built model and also provide an understanding of the interactions between different building elements. However, remodeling of BIM models in FEA can be time-consuming, and also there might situations where there is oversimplifications of specialized geometry, and this might be costly in terms of it might cause errors, and also this hampers the iterative nature of construction and the whole building life cycle. So it's really necessary to develop a methodology or also to automate a methodology for transferring both the geometry and the information between these two platforms. So to really develop a methodology, it was necessary to understand how data is exchanged within BIM platforms and also between BIM and FEA softwares. So these are two ways which data is exchanged. It can either be exchanged through direct links and indirect links, among other ways, but this was the focus. So direct links, they rely on middleware softwares, which with interfacing capabilities to connect to applications using programming languages such as C and C#. Examples of direct links are Revit to Autodesk Robot, or Revit to Sophistic, Revit to Shear Engineer, and also Tekla structures to FEM design. Whereas on the other hand, indirect links are achieved using file formats that are in human readable text formats. For example, the industrial foundation structures, which is a data schema developed by Building Smart, and also the structural analysis formats, the SAF, which is developed by the Nameshek group. These two data schemas are open source, and they are rich with both the geometrical information and the analytical information, such as the cross-section properties, the density, the Young's modulus, the Poisson's ratio. So a case study was tested out. We'll see further in the presentation the methodology that was used to implement the case study. So one was to really transfer the BIM model from Revit to ANSYS, either as a wireframe model, which is 1D, 1D and lines and surfaces, and also as a solid geometry consisting of volumes. And then on the other hand, also transfer the same geometry using the structural analysis format, just to compare the robustness of the workflow of transferring the model from BIM to ANSYS. So the case study was a simple geometry developed during the module, which consisted of a girder beam supported by pier and piles with pile caps, and only self-weight was considered for the transfer of the information from BIM to ANSYS, and a fixed support was put at the bottom of the piles. So this IDF diagram summarizes the methodology used to transfer the BIM model from BIM to ANSYS, both as lines and surfaces and as a solid geometry consisting of volumes. But the focus will be on these four aspects: the exportation of the BIM model. For this presentation, the focus will be the exportation of the BIM model, the modification of the geometry, the assignment of the structural profiles, and the extraction of the sections and surfaces. The rest of the methodology is well defined in the thesis. So the exportation of the model includes exportation of the model as lines and surfaces, includes extractions of the analytical model using Dynamo in Revit. And then after extracting the lines and surfaces, the model was exported using the SAT format to ANSYS. And then also the solid model was exported to ANSYS as the BIM model was exported as a solid model to ANSYS using the SAT format, using Revit export tools. And then also it was exported to ANSYS using IGS and step formats, using IFC as an intermediate step, because ANSYS does not really support the does not really implement the IFC, but it does so as using the step format. And this was done using FreeCAD. Upon importing the model into ANSYS, ANSYS has a software program called ANSYS Space Claim and ANSYS Discovery. And these tools are used to really repair the model. And repairing the model includes assigning material, assigning section profiles to lines and also checking whether there are any gaps, in the model. This shows the interface of ANSYS Discovery, and this allows us to extract profiles from the solid geometry, and these profiles can be saved in the profile library, which can be assigned to models imported as lines and surfaces. And also this helps repair geometry if there are any gaps, because when you extract a profile from a solid geometry, it creates an analytical line at the neutral axis of the model, and this might cause gaps within the analytical model. So therefore, there is need to really fix these gaps, and there are several tools within ANSYS Discovery and also ANSYS Space Claim, which helped to repair the geometry. And this applied to the lines and surfaces model, whereas in the solid model imported into ANSYS, there are also other tools that were used to really check if they're repeated surfaces, if they're repeated lines, which will be a problem when generating meshes in ANSYS mechanical. And then as I mentioned, the extracted sections and surfaces can be stored in the profile library, which can be later assigned to any new lines and wireframe models imported into ANSYS. So that is how the BIM model was transferred from the BIM environment to ANSYS. And then the next was to really use the structural analysis format to using the same model to really see the robustness of the methodology developed for transferring the model from BIM to ANSYS. So this schema summarizes the implementation of the structural analysis format. The structural analysis format was developed by Lemashon, and it's based on an Excel schema. So it included the exporting of the model from Revit as IFC and importing it to ArchiCAD and checking each element if the structural properties are defined. Structural properties, this means that the model was not exported to IFC as a generic, but really a BIM was exported as an IFC BIM. The column was exported as an IFC column. And if the structural properties were defined, it was then to check whether the load-bearing property, this was all done in ArchiCAD, to check whether the load-bearing property was defined. This can be when you select the model, you can go to the structural analytical properties in ArchiCAD, and this can be chosen from the drop-down menu. And then if the load-bearing property is defined, then the analytical model can be automatically extracted in ArchiCAD using the internal tools in ArchiCAD. And then the next was to check whether the model was continuous. And if the model was not continuous, then using ArchiCAD, you can define structural links, which are rigid bodied links, which show how load is transferred from one structure to another. And then follows defining the load cases, assigning supports to the model, and then defining the SAF translator. So the translator basically, different software programs interpret material and geometry different. And these translators really help in mapping the geometry and the materials from one software program to another. This shows the SAF, the structural analysis format translator in ArchiCAD, and it checks all the model and checks all the materials available, all the profiles used, and then the user can then choose how this profiles and materials will be translated to the receiving softwares. In this case, the receiving softwares were FEM design and share engineer. So this was changed accordingly, and the model opened in FEM design as SF format and share engineer, and structural analysis, various problems solved. So these are the numerical results for the shear and the moment. It shows this was just to compare how robust the methodologies were. So the investigation of the maximum bending moments, the extreme values of the shear, and the locations for the different file formats. So on the top right, we have the results for the shear and bending moment in ANSYS. The model was this shows the model imported in the using the SAT2D format. And then the bottom shows the results of the same model imported using the SAF format. And we can see that there is a standard deviation of around 40 kilonewtons per meter, 40 kilonewtons meter for the bending moments, which shows the consistency of the, which really shows that there is consistency of the model using the different file formats. The other numerical result that was observed were the deformations using the different file formats. And these deformations were only under the self-weight of the structure. So this shows that also there's a really minimal deviation, a deflection among the different file formats. And we can see that we have the SAT, the file imported to ANSYS as a wireframe, and also as a solid model in SAT step and IGS format. And there's also minimal deviation between the deflection. The other investigation was a model analysis in ANSYS. This was to really check how the structure vibrates at its natural frequency. And there was a consistency also in the eigen mod shapes for the modes with the highest effective masses in the Z direction. This shows the compared also the frequency and the mode shapes. There was really consistency among the different file formats. To conclude, the deliverables for the test is the methodology for the transfer of geometric data from BIM to ANSYS, and also briefly the implementation of SAF format was tackled, and also comparing these different workflows and the robustness and the strength and the weakness of the different workflows. The limitations were that for the transfer of the model from BIM to ANSYS, it's still unidirectional, and there aren't any method developed to transfer the model back to the BIM environment. And also extraction of the profiles was limited to the BIM elements having a uniform cross-section. And also there were manual intervention on certain aspects. The opportunities were really the methodology developed will help in monitoring real-time performance of structures, and also predictive maintenance and life cycle management of existing structures. And further development of this work will be to automate the methodology using the structural analysis format, because it's really tailored for analytical information and easy to follow. Thank you for your attention.